Our new pattern for this time around is our sum and difference of two cubes. I remember it by calling it the SOAP pattern. SOAP stands for same sign, and then next comes the opposite sign. Your last sign will always be positive. So if I've got a cubed plus b cubed, I always write that out by saying, okay, my first set of parentheses is going to be a and b, and then you've got a squared, multiply the two together, get b squared. And then your signs follow the SOAP pattern. So a cubed plus b cubed, oh, same sign, opposite sign, always positive. So similarly, if you've got a cubed minus b cubed, the cubed root of that first term goes as your a. So you've got a, and then you've got b, which will be the cubed root of your second term. Then a squared, ab, b squared, your signs, oh, minus, these are going to be the same, the opposite sign, and then always positive to end off. So x cubed minus 8, well, to figure out my a and b values, I say, okay, what is the cubed root of x squared? What is the cubed root of 8? So my a is just going to be x, and my b is going to be 2. So when I factor that guy, I've got a and then b, so x and then 2, and then I've got a squared, ab, b squared. My signs go same, opposite, always positive. You're done from here. Now, we always will end with something like this that will make us stop and wonder if we can factor it. You never will be able to, though. So you'll always have to stop right there. Now in example 17, what is your a, what is your b? We'll start by taking the cubed root of your first and second terms. So it looks like your a is going to be 3y. Your b is going to be 4x squared. So when you set up those parentheses, you'll have a and b, a squared, and then ab. Let's see, 3 times 4, we get 12, x squared y, nothing special there. And then b squared would be 16x, oopsies, to the 4th. Your signs follow the pattern. Same sign, so minus, it's going to start with a minus. Opposite sign, always positive. And there we are. Alrighty, so as we put it all together, we are going to use factoring to solve, or sometimes I'll even say solve by factoring. So in example 18, I first want to start by looking for a GCF, and sure enough, I've got one. So I take a 2 out of everything. I'm left with 4y squared minus 9 equals 0. Well, sure enough, those are, or that's going to follow the dots pattern. So as I continue to factor, I've got 2 times 2y plus 3, 2y minus 3 equals 0. And our zero product property tells us, well, if you've got 2 things that multiply to give you 0, well, one of them has to be. So you set them both separately equal to 0. 2y plus 3 equals 0. Subtract 3, divide by 2. Y could be negative 3/2. Or you could have 2y minus 3 equals 0, add 3, divide by 2. It could be a positive 3/2. Now we don't have to worry about this 2 that we divided out because there's no variable attached. So if you ever take out a GCF that doesn't involve a variable, don't bother worrying about it again. In example 19, we want to look for a GCF. So it looks like our greatest common factor among those 3 terms on the left-hand side of the equal sign going to be, looks like just a 2x actually. Not as exciting as I was hoping. So I take a 2x out of everything. I'm left with 10x squared plus 13x minus 30, yep, equals 0. I'll have to solve that one by using our tricky try formula. So multiply a and c, you get 300. You need 2 numbers that multiply to 300 and subtract to 13. Those numbers are going to be, let's see, 12 and 25. So your 2x, I'm actually going to go over here, is along for the ride, and then you've got x and 25, x and 12. Don't forget these are equal to 0. Signs are different. Your bigger sign, or your bigger number, is positive. X plus 25, x minus 12. divide and slide by your new leading coefficient, your 10, not your original 20, because you already got rid of the 20 and called it the 2x out front and then the 10x squared. So we're going to divide and slide by 10. We're able to reduce both of those. That becomes a 5/2. That becomes a 6/5. So you have 2x times 2x plus 5 times 5x minus 6. Those are all equal to 0. Now, this time our greatest common factor did include a variable, so you do have an additional solution. It's 0. And then setting that first set of parentheses equal to 0, you get negative 5/2. Setting that second set of parentheses equal to 0, you get a positive 6/5. So there are all your solutions. In example 20, our GCF is going to be 5x squared. So then we're left with x squared plus 4 equals 0. Now, from here, we do set both of those chunks equal to 0. So 5x squared equals 0. Oh, x must be 0. And then setting the second chunk equal to 0, x squared plus 4. We start by subtracting 4 from both sides. And now that we know about imaginary numbers, we can solve this. So x equals the plus or minus square root of negative 4, which will give us plus or minus 2i. So there's two of your solutions, and then you've got x equals 0. Example 21, we start by taking out a GCF, so it looks like we are going to be able to factor out a 4. Nothing more exciting than that. And we're left with w to the 6th plus 10w cubed minus 11. Now, notice that we go from w to the 6th to w cubed. Remember, if it's got an even exponent and then you take that exponent divided by 2, that's the next time you see it, you can use your trinomial pattern and you're going to use your u substitution. So we want to let u be w cubed, and then we will rewrite that as 4 times u squared plus 10u minus 11. Well, that's going to be a lot easier to solve. You'll have u minus 1, u plus 11, and then we plug u back in because we didn't have to divide and slide. So we plug u back in. 4 times w cubed minus 1 times w cubed plus 11. All right, so w cubed minus 1, we now know that we can factor that using our SOAP pattern. So that 4 out front along for the ride. We'll have w and 1, w squared, 1, w, 1. Our signs are going to be the same. The opposite, always positive. Now we cannot factor out that last chunk. That's okay. We're left with w cubed plus 11 equals 0. And setting all these guys separately equal to 0. We don't care about that 4 because he was not included with a variable. So just 4, nothing special. So that guy, we get 1. That's fun. This guy, like I said, we'll never be able to factor, but we can solve using the quadratic formula. So x equals, or I guess w, whatever, equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1, so minus 4. So under our radical, we'll have a negative 3 all over 2 times 1. And we'll call that instead negative 1 plus or minus I root 3 all over 2. And solving that last chunk, we are not able to use our our SOAP pattern because 11 is not a perfect cube. But that's okay, because we can say w cubed equals negative 11. So we subtract 0 from both sides after setting it equal to 0. Take the cubed root of both sides. We can take the cubed root of a negative number. That solution is not imaginary. It's just the cubed root of negative 11, whatever that is. And there are all our solutions. Last one, example 22, we want to get 0 on one side first, so we are going to subtract 27p cubed from both sides. So I have 48p to the 5th minus 27p cubed equals 0. We we are going to take out a GCF. I can take a p cubed out of both, and 48 and 27 are both divisible by 3. When I do, I'm left with 16p squared minus 9. Hey, 16p squared and 9, those are both perfect squares. So I've got 3p cubed times 4p minus 3 times 4p plus 3 equals 0. So from this guy right here, 0 is a solution. From this guy right here, positive 3/4 is a solution. And so is negative 3/4. There are all of our answers. So hopefully that was helpful for section 5.4, solving by factoring. Now we are still planning to have a quiz on Tuesday, so please be prepared for that. For those of you juniors that were gone on Friday, first of all, congratulations on a very successful PA. That was wonderful. But please plan to have the section 5.4 homework to me ready to go on Tuesday. So you'll get Monday off you'll get an extra day to do your homework since you were not in class on Friday. So if you have any questions, please feel free to email me or come visit me after school.